When the water from two seas met, something incredible happened. They refused to mix. Do you want to find out what? Then stay until the end of the video. At the southern tip of Chile, there's a place where the seas meet and don't mix. The Atlantic and Pacific Oceans come together here, but they don't blend. Instead, they stay separate, and it's all because of their different temperatures. The warmer water of the Pacific doesn't mix with the colder water of the Atlantic. They form a sort of boundary where the two water masses meet, but don't combine. This is a strange phenomenon that has been observed for centuries, but it wasn't until recently that we learned why it happens. It's not just the temperature difference that keeps these two bodies of water apart. There are also differences in their salinity levels, density, and even color. It seems like they're just too different to ever mix, yet they do eventually combine. It just takes a lot longer than you might think. But when they do mix, what will happen then? Will a new sea be born, or will it be a disaster? Scientists have been trying to figure this out for years, and now they may finally have an answer. A recent study published in the journal Nature Physics has shed some light on why these two very different bodies of water don't mix, and how long it takes them to do so. According to the researchers, it can take up to 100 years for the two waters to fully mix. That's a very long time, but it's also an incredibly rare opportunity to study the behavior of two large bodies of water as they interact with each other. Scientists believe that by studying these two bodies of water, we can learn more about how the climate is changing and how that's affecting our planet. These two bodies of water are more than just a scientific curiosity. They're also a beautiful natural wonder. The boundary between them is known as the Cape Horn, and it's a popular destination for sailors and tourists alike. The strong currents and unpredictable weather make it a challenging place to visit, but the stunning scenery is worth it for many people. But what exactly is happening at this unique meeting point? Why don't these two bodies of water mix? Why is it such a challenge to study? Let's start with the basics. The Atlantic and Pacific Oceans are two of the largest bodies of water on Earth. They cover more than 70% of the planet's surface and contain more than 97% of the Earth's water. But despite their size, these two oceans are very different from one another. They have different temperatures, salinity levels, and densities, which means they don't mix easily. The temperature difference is the most obvious. The Pacific Ocean is generally warmer than the Atlantic Ocean, and that's why the water from the two oceans doesn't mix when they meet. Hotter water is less dense than colder water, so the warm water from the Pacific Ocean stays on top of the colder water from the Atlantic Ocean. This creates a clear boundary between the two bodies of water, and it's this boundary that's so fascinating to scientists. But the temperature difference isn't the only factor that prevents these two bodies of water from mixing. The salinity level of the two oceans is also different. The Atlantic Ocean is saltier than the Pacific Ocean, and that's because of the amount of fresh water that flows into it. When fresh water enters the ocean, it lowers the salinity level. The Pacific Ocean receives less fresh water than the Atlantic Ocean, so its salinity level is higher. This difference in salinity also contributes to the boundary between the two bodies of water. In addition to the temperature and salinity levels, the density of the two bodies of water is also different. The density of water is affected by both temperature and salinity. So the warmer and saltier water of the Pacific Ocean is less dense than the colder and less salty water of the Atlantic Ocean. This difference in density makes it even more difficult for the two bodies of water to mix. The color of the two bodies of water is also different, although that's not a scientific factor that prevents them from mixing. The Pacific Ocean is generally a darker blue than the Atlantic Ocean, and that's because of the amount of organic matter in the water. The Atlantic Ocean has more organic matter than the Pacific Ocean, so its water is a lighter blue. Despite these differences, the two bodies of water eventually do mix, but it takes a long time. Scientists have estimated that it can take up to 100 years for the two bodies of water to fully mix. That's because the boundary between them acts as a barrier to the mixing of the water molecules. The molecules in the two bodies of water can't move across the boundary, so they stay separate. However, over time the molecules do begin to diffuse across the boundary, and eventually the two bodies of water become one. This mixing process is important for a number of reasons. First, it helps to distribute heat around the globe. The warm water from the Pacific Ocean is carried to the Atlantic Ocean, where it helps to warm the climate. Second, it helps to circulate nutrients in the ocean. The mixing of the two bodies of water brings nutrients from the depths of the ocean to the surface where they can be used by marine life. Finally, it helps to regulate the Earth's climate. The mixing of the two bodies of water helps to absorb carbon dioxide from the atmosphere, which helps to keep the Earth's climate in check. Studying the mixing process can help us understand how the climate is changing and how that is affecting our planet. By understanding the factors that cause the two bodies of water to mix, we can better predict how the climate will change in the future. It's not easy to study the mixing process because it takes so long to occur, but scientists have developed new techniques that allow them to monitor the mixing process over time. One technique is to use satellites to measure the temperature and salinity of the two bodies of water. Another technique is to use computer models to simulate the mixing process. These techniques have allowed scientists to learn more about the mixing process than ever before. Scientists are still working to fully understand why these two bodies of water don't mix and how the mixing process works. But they've made some interesting discoveries. For example, they've found that the temperature difference between the two bodies of water is the main factor that prevents them from mixing. They've also found that the mixing process is more complex than they originally thought. The two bodies of water don't just mix together, they form a kind of rotating vortex that eventually breaks down over time. This mixing process is similar to the way that fluids mix in other systems, such as in a chemical reaction. One of the most amazing things about this phenomenon is that it's so visible from space. The two bodies of water are so large that they can be seen from satellites orbiting the Earth. This has allowed scientists to monitor the mixing process over time and make some incredible discoveries. In addition to the scientific value of studying these two bodies of water, there's also a cultural value. Cape Horn is a place of legend and folklore. It's said that the waters around the Cape are some of the most treacherous in the world, and it's been the site of many shipwrecks. The strong currents and unpredictable weather make it a challenging place to navigate, but the stunning scenery is worth it for many sailors. The intersection of the Atlantic and Pacific Oceans is a truly remarkable phenomenon. The two bodies of water are so different from each other, yet they eventually come together to form a single body of water. It's a reminder of the power of nature and the importance of understanding the world around us. By studying these two bodies of water, we can learn more about the climate and the environment and better understand the challenges facing our planet. And if you liked this video, please share it with your friends. Until next time, thanks for watching.